afternoon, dear scientists. It's 4 p.m. and we are starting our meeting. Our team of moderators is working with you today. Olga Bondarenko, Pavlo Nechepurenko, and Stepanova Yelizaveta. Welcome to the section Earth Science Education, Technology Education. This session is a part of conference IConMaSTEd 2023. The International Conference on Mathematics, Science and Technology Education is a peer-reviewed national conference which covers research on mathematics, science, and technology education, along with technology-enhanced learning, including blended learning, e-learning, ICT-based assessment, mobile learning, etc. Since 2021, IConMaSTEd is the premier interdisciplinary forum for social scientists, academics, researchers, professionals, policymakers, postgraduate students, and practitioners to present their latest research results, ideas, developments, and applications. Thank you in advance for your participation in our conference. And we are looking forward for fruitful cooperation over the next 2 hours. But before we start, let us remind you of some rules of our cooperation. Please follow the regulations. We have 15 minutes for discussion. They include 10 minutes for presentation and 5 minutes for questions. We hope that you, as well as us, are in a safe place. If you have any questions for our speakers, you may ask them after the presentations, in chat or orally, but before this, raise your hand at the bottom of your screen. The language of our meeting is English, but if you may need our help, we can help you to translate it. So let's start. The word is given to Bryaznitseva Anastasia from Kruty Heroes Military Institute of Telecommunications and Information Technologies. And the topic of presentation is the use of ICT for mathematical calculations in the water quality assessment in the teaching of ecologists.
Dear participants of the conference, the results of scientific work are presented to your attention, demonstrate the possibilities of using computer technologies in the modern educational process of teaching ecologists in practical classes in the discipline Conservation and Proper Utilization of Water Resources, containing mathematical calculations. The normative content of the standards of higher education for bachelor teaching in the specialty ecology determines the program results of teaching, among which, along with the ability of graduates to solve problems in the field of environmental protection, attention is drawn to the need to use software tools, GIS technologies, choose the best methods and tools for environmental research, data collection and processing. The implementation of one of the state environmental policy tasks is to ensure the protection and rational use of water resources is possible only if the water quality of the water body is rationing. Therefore, special attention and relevance in the process of teaching ecologists acquire practical works of the environmental assessment of the state of water bodies through lengthy and cumbersome mathematical calculations. One of the means of increasing the efficiency of water quality assessment of water bodies is the operational processing of information on the status of water quality, which is achieved through the use of ICT. This is relevant for expediting the process of assessing the state of water bodies and for the formation of the general competence of the future ecologist, skills of using information and communication technologies to solve complex specialized environmental problems. Recognizing the complexity and scale of goals in the field of environmental protection, teachers and scientists declare that it's possible in practice to achieve them, but acknowledge that temporary criteria and rationing of the educational process often lead to the inability to spend a lot of time on intermediate stages and calculations. Therefore, we suggest the way to speed up mathematical processing of environmental information using information communication technologies, and free up time to teach students to analyze, assess, and make decisions about a problem. An example is the experience of implementation into the process of learning the discipline conservation and proper utilization of water resources. The automatic mathematical calculations on the practical classes which are dedicated to determining water quality according to existing methods. In the two most simple water quality assessing methods, calculations are made for 6 hydrochemical ingredients. The sequence of assessment consists of 2 stages. At the first stage, the indicator value is calculated, and at the second, the verbal characterization of water quality is given according to the calculated index, value, and the quality scale. The third method consists of several steps. The entire process is carried out according to the observed hydrochemical ingredients, the number of which can be 40 or more. In addition, the procedure can be performed according to one of the 3 and/or for all 3 current water quality standards. For more information on water quality assessment methods, please refer to our article. We developed a software product that allowed replacing the manual processing of ecological information. Previously, the number of hours that was allocated for assessing the water quality in water bodies according to the discipline curriculum was enough only for processing according to the 2 simplest methods, according to one type of standard. Using a computer allowed within the same practical works also to perform processing according by 3 methods. In addition, there is enough time for calculations for all 3 types of standards. Students manage to perform a comparative analysis of the results and make a list of recommendations for solving the ecological problem. The developed software consists of a local database, an interface for interacting with the user, a reporting system, and the calculation automation system, as indicated in the scheme. The main program window consists of an interface for presenting tabular data, a section for sorting data by date, a section for entering data, and a section for choosing a method for calculation of surface water quality. According to the results of measurements, the student enters into the table the values of the ingredients for the corresponding date. Next, choose the assessment methods, standards according to which calculations will be made. The program assesses the water quality by pressing the Calculate button, and the calculation results are displayed above the table in the text form. The calculation windows for each of the 3 methods are presented on slides. The created software allows students with primary knowledge of the basis of working with a computer to use it both for educational purposes and in their future professional activities. The software product has clear user instructions for working with the system, a convenient and simple interface, easy of data entry, the ability to expand the number of indicators that are used to analyze water quality. Automation of mathematical calculations made it possible to reduce the time of practical work by 6 times. Previously, manual water quality assessment was performed during the one practical lesson, 90 minutes. Now, 15 minutes is enough to form an array of data and immediately receive the assessment results. The remaining time allows students to determine the quality of water not by one, but by 3 methods. Perform a comparative analysis of the results and make a decision on the possibility of using the water body for the needs of a particular water user. 5 years of practical experience in the discipline, conservation and rational use of water resources with the use of ICT allows us to claim that students not only quickly, accurately and reasonably establish the fact of an environmental problem, pollution of a water body, but also acquire the ability to analyze critically the received information. Thus, the basis of system analysis are formed in future ecologists' thinking, which are necessary for the formation of large-scale and strategic decision-making thinking in the field of water management. Computer program developed and integrated into the educational process of students, ecologists in a complex of practical works on the discipline, conservation and rational use of water resources for mathematical calculations. This made it possible to reduce the time of practical work by 6 times, to increase the number of studied methods for assessing water quality, to perform a comparative analysis of the results and to make a decision on the possibility of using a water body. The further introduction of information communication technologies in education will optimize the educational process, enhance the cognitive and creative activities of students, increase efficiency and productivity, create conditions for in-depth learning of special disciplines. Thanks for your attention.
Dear colleagues, thank you for your presentation. Colleagues, do you have any questions?
Можна задати запитання. Вибачте, але я все ж таки вирішив не смішити присутніх своїми потугами самому зачитати англомовний текст. Значить, в мене таке запитання до пані Анастасії. От ви забезпечили сумісність розробленого вами програмного забезпечення з Windows. У вас зазначено з різними версіями Windows. А чи сумісне ваше програмне забезпечення з іншими операційними системами, вільно поширюваними, наприклад?
Добрий день, шановні колеги. Thanks for your question. I'll try to answer in English if you don't mind. Yes, unfortunately, our program product don't have can't be used in other operation systems, but we know that their most useful system is Windows, so we don't even have such purpose to create some product which we can use in other operation systems.
Тобто через
Thank
те,
you very
що
much.
Thank you.
Dear colleagues, the questions of Pavlo Pavlovich was, is it possible to make some things that concerns to the use this developed software in other environment, for example, in the free on the OS operation system like Linux. these questions is important for the educational institutions in Ukraine, especially in wartime. For example, in KRYVYI State Pedagogical University, all our computer classes are based explicitly in the Linux Mint, Linux Ubuntu, or like systems. Thank you.
Thanks for your question. I hope that I understand everything right, but unfortunately, it's a difficult process to make any change in this program product to make it possible to use it in different platforms. So if we need to use it in some other environments, we need to make another program.
Thank you, Anastasia, and thank you, your dear colleague, Professor Shachman. We are excited to see our Kherson College, even temporarily, I think it's temporarily relocated to Kyiv in our famous military university. Thank you one more time. Looking for the not only next year and our very coming soon next events. Thank you.
Thank you a lot. So let's move to the next presentation. And the topic of next talk is digitalization of geographic higher education, problems and prospects. And the speaker is Olga Bondarenko from KRYVYI State Pedagogical University.
Good afternoon. Dear colleagues, we are pleased to present you a research on the topic digitalization of geographic higher education, problems and prospects. The relevance of the research problem is determined by a range of contradictions, namely between the social significance of the geographic education digitalization and its actual state, between an ever-increasing amount of independent and individual work of students and the necessity to facilitate all types of educational and cognitive activity of geographer students anytime and anywhere with available and appropriate means of GIS technologies, ICT, and mobile ones particularly. Between the potentials of modern digital technologies and an inappropriate level of their mastering by students and teachers of higher education institutions. Overall, educational digitalization requires as corresponding scientific and methodological as technological and financial support. We envision the solution of our research issue in the theoretically substantiated and practically approved methodical system of digitalization of geographic education via creating the informational educational environment of higher educational institutions. The latter comprises the implementation of digital technologies, GIS, mobile, and cloud ICT, taking into account the methodological conditions, and aims at the formation of professional competence of future geography teachers, specifically digital one. However, this publication focuses on defining the concept of digitalization of geographic education, clarifying its essence, advantages, and disadvantages. The article aims to determine the essence and the content of digitalization of geographic education in secondary and higher school, to disclose the challenges and prospects of its development. The problem we are studying has been the subject of research for many scholars. This is shown on the slide. The abrupt and mass transition from the real classrooms to virtual networks brought to life radical changes in the organization of the educational environment and accentuated the urgency for the general digitalization of education, and specifically geographic one. The latest scientific literature interprets digitalization of education as the introduction of modern ICT technologies into the educational process, aiming to equip the youth with the 21st century skills, for instance, to analyze the reliability of received information, to apply critical thinking, etc. Educational digitalization involves extensive use of varied multimedia content for educational purposes and interactive learning methods for the intensification of educational process. Digitalization of education assumes the augmented, virtual and mixed reality, cloud, mobile and internet technologies, educational gamification, distance learning, open online courses for mass audience, and the launch of digital universities. It is a prerequisite for the raise of the level of organization of the educational process, the assurance of the availability of electronic resources and services, the increase of ICT competence level among students and teachers. We consider the digitalization of geographic education to be the introduction of modern digital technologies in the process of geographic disciplines study aimed at the formation of future teacher professional competence. The implementation of geographic education digitalization may ensure the sustainability of the overall educational process and the professional training of future geography teachers, especially in the conditions of social crisis phenomena. The geography students should acquire skills by working with appropriate equipment and software such as GIS, digital weather stations, tools for creation of new generation electronic educational resources while taking geography courses, and thus develop their professional competence. The digital technologies in geographic education will provide an opportunity to explore various physical and socio-geographical objects, phenomena and processes, to identify their causes and predict their effects on sustainable social development. Nowadays, digital technologies evolve extremely rapidly, so their implementation in the education has a number of advantages that affect its quality. The remote mode enables students to master geographic disciplines synchronously or asynchronously outside the classroom, regardless of the location, to adapt the pace and schedule of study to their individual needs. The digital technologies open up many new opportunities, primarily related to multi-channel pedagogical communication, video lessons, presentation, teachers' live speech, student group chat, etc. VR and AR technologies are gaining their importance in geography education as they offer a new and innovative approach to the study of geography, making the process more interactive and engaging for the students. These technologies can visualize the object as much as possible. If previously many geographical phenomena and processes were presented in 2D format, now they can be in form of 3D models available in normal, analytic, or stereoscopic models. Students receive information in a ready-to-perceive look without spending time and cognitive effort on its interpretation. Educational AR and VR technologies enrich visual and contextual learning, improving the content of information and contributing to the productive assimilation of what is learned. However, the global transition to e-learning has vividly manifested a great lack of tried and tested, uniform educational methods in digital pedagogy. Teachers of higher education institutions worked out their methods by trial and error or borrowed them from related fields. It has business or television online conferences, business trainers, and even teenage streamers. So geography teachers were no exception. The general analysis of the experience of digitalization in geographic education uncover a variety of technologies currently employed by teachers in the education process. The review of the methods of geography teaching argues that secondary school teachers most often make use of some digital technologies of general purpose, for example, class time, learning apps, Nowrock, scribing technologies, blogs, online puzzle generators, tapes, tests, etc. The above-mentioned technologies help to acquire knowledge of geography and provide communicative interaction between a teacher and students. Higher education institutions mostly implement GIS technologies such as Google Earth or Google Maps, which train students to work with cartographic materials. Geography teachers in secondary school very rarely put into practice specialized digital technologies, if ever. All above facts considered bring to light certain problems in geography teaching practice. Narrowing the digitalization of geographic education to the use of various gadgets or general-purpose digital technologies. Underestimation of GIS technologies, technologies of remote sensing of the Earth, satellite navigation. Occasional use of VR, AR technologies, mobile applications with cartographic content, etc. Geography students may be unaware of wide range of services and applications used at school due to their diversity. A teacher tends to use the limited technologies that he managed to master on his own without proper methodical support. Specialized digital technologies, particularly cartographic ones, are rarely used in school practice due to the lack of necessary educational and methodological support and proper technological access. The list of observed problems and pitfalls cannot be considered exhaustive, since the application of digital technologies causes a number of other challenges of a technical and physiological nature. Yet, the humanization of the education in the age of digitalization requires a teacher to manage students' educational motivation during group facilitation as the self-organization basis. However, we do not dwell on the detailed characteristics of all the difficulties, as we only note that the real state of educational digitalization, especially geographical one, unfortunately does not fully correspond to social needs at the level of modern geographical science development. The potential possibilities of digital technologies are much wider than the level of their use in educational practice. In connection with the above stated, we envision the prospects for further digitalization of the geographic higher education as following. We believe that the implementation of the specified aspects of digitalization of geographic higher education in the near future should have a positive effect on the professional competence of future geography teachers, their commitment to professional development, and mastery of information technologies. The theoretical generalization of scientific resources and the analysis of educational practice let us consider the digitalization of geographic higher education not only as one of the actual directions of its modernization, but also as a rather promising way of popularization of geography among students. Modern digital technologies have powerful didactic opportunities for daily learning exploration of planet Earth. They love studying the Earth in its physical dynamics and the world in its socio-economic aspect. We see the prospects for further scientific research in solving the following tasks: to determine the state, directions, and prospects of digitalization of geographic education, to develop a model of the methodical system of digitalization of geographic education, and to identify methodical conditions for its effective implementation. To implement digital technologies in higher education institutions in order to form the professional competence of future geography teachers. To check experimentally some components of the projected methodical system of digitalization in geographic education. To develop methodical recommendations for the implementation of the methodical system of digitalization of geographic education. Thank you for your attention.
So if you have any questions, you may ask them.
Ну що, давайте знову я. Так, пані Ольга, скажіть, будь ласка, от серед тих програмних засобів, які от у вас були перераховані, да, опрацьовані в табличці, яке співвідношення, знову ж таки, між проприєтатним і безкоштовним програмним забезпеченням? Тобто, чи можемо ми собі дозволити все те, що було перераховано?
Thank you. The question of Pavlona Chiporenko was among the software which proposed to achieve the goal of digitalization of geography education, which software is proprietary and which of free software? Which percent of free software are you proposed to use to achieve this goal? Thank you.
Good afternoon. I will say the answer in Ukrainian, and later or Sergey Alexeyevich will translate it. Пал Палич відповім вам українською. Якщо потреба буде перекласти, то я сподіваюся, Ліза або Сергій Олексійович перекладуть. В своїй публікації ми відстоюємо провідну позицію, що загалом цифровізація географічної освіти, вона потребує відповідного науково-методичного забезпечення, технологічного належного супроводу і, безперечно, фінансового забезпечення, тому ваше питання якраз стосується фінансового забезпечення. Важко однозначно відповісти на ваше запитання. Чому? Тому що ми маємо суперечність між тим, до чого готовий майбутній вчитель, і який в нього в арсеналі є, якими він готовий користуватися програмним забезпеченням. Найчастіше це спеціалізоване програмне забезпечення, яке, тут треба сказати, що не так багато, але хмарні у вільному доступі є. Це, наприклад, Quantum DataGIS, це, наприклад, ArcGIS, ну і, власне, мабуть, і все. Якщо говорити про школу, то школа, наприклад, менше спеціалізоване програмне забезпечення використовує, але більше забезпечення загального призначення використовує. І тут не завжди наші студенти готові охопити весь той арсенал методичний, який сьогодні використовують вчителі. Тому, в принципі, для того, щоб успішно викладати уроки географії чи то в школі, чи то в вищій школі, у вільному доступі є, але якщо говорити про програмне забезпечення в співвідношенні, я б сказала, що все-таки 1/3 буде доступна у вільному доступі, а 2/3 – це те, що потребує підписки, і дуже часто підписки дороговартісні. Знаю, що школи трохи краще вирішують цю проблему, вони оформлюють ці підписки. Що стосується закладів вищої освіти, зокрема, наша кафедра працює над тим, що знайти тоді додаткові джерела, за рахунок чого можна було б оформити ці підписки, і власне, окремі кроки в цьому зроблені.
So, if to summarize, in general, we have 1/3 of all the things for free, and 2/3 are to buy. And schools usually buy them. What we can talk about universities.
Yes, thank you. I would like to some extent the answer of Olga Volodymyrovna. Accordingly to her answer, the three main things we need to take in our attentions, which according to the achievements, the digitalization goals. First of all, is the training techniques, methodology of geography education. Second part is especially the software, related software. And the last part is our finance. Accordingly to Dr. Bondarenko answer, we have different financing in the different type of educational institutions. For example, our secondary education in Ukraine has much bigger abilities more than higher educational institutions. A lot of software exist both in free and proprietary versions, but some related software to the geography education, it exists in only high quality proprietary version. So the main goal when we would like to build a high quality geography education is a good financing to make some paid subscriber on the usual or cloud-based software like Quantum, GIS, etc. Thank you.
Thank you.
So we
Можливо, ще
continue
якісь
our talk.
запитання будуть?
Okay.
Можна тоді ще одне? Так, Ольга Володимирівна, скажіть, будь ласка, у вас описано, що ці цифрові технології будуть викладатись в курсі цифровізація географічної освіти, який розроблений для магістратури. Чому саме для магістратури, а не для бакалаврів?
So you said that these courses will be taught for masters, and why they are taught for masters and not for bachelors?
Дякую за запитання. Тут все дуже просто. На рівні першому бакалаврському вищої освіти є кілька цифрових курсів: цифрова картографія і гіс-технології. Тому вводити до навчального плану ще один освітній компонент, ну, скажімо, не бачили потреби, тому запропонували, це пов'язано із внутрішніми також такими, значить, з внутрішнім менеджментом зараз переглядаються, в принципі, навчальні плани в магістратурі, тому ми запропонували узагальнюючий за характером курс, який буде саме для магістрів. Він буде підсумовувати все те, що вони вивчили і за попередніх 4 роки, і передбачаємо, що там якраз буде 2 тематичних модулі. Перший буде присвячений програмному забезпеченню загального призначення, тобто розглядатимемо і освітні платформи різноманітні, і хмарні якісь технології. А якщо говорити про другий тематичний блок або тематичний модуль, то він буде якраз спрямований на те, щоб викладати спеціальне програмне забезпечення, тобто якраз у ті ДЗЗ, дистанційне зондування землі, гіс-технології, супутникову навігацію. У такий спосіб ми намагатимемося подолати оцю от різницю між тим, що шкільний вчитель готовий використовувати одне програмне забезпечення, а наш студент готовий використовувати інше. Хочемо, щоб він, прийшовши до школи, був готовий, в принципі, використовувати як спеціальне, так і загального характеру, загального призначення програмне забезпечення. Тому ось десь це реально внутрішнє якісь, кажу, питання внутрішнього менеджменту. Ну і вже якщо так трапилося, то це буде узагальнюючий комплексний курс, який засвідчить уже рівень готовності до професійної діяльності майбутнього вчителя географії.
So if we talk about bachelors, we have like general courses, and there are 2 courses for bachelors, but for masters, there is more focus on inner management. So we have summarizing course, And in the first block, we have general programs. And in the second model, we have some special programs. So that's it.
Thank you, Lisa. My small addition, according to the Olga Valdemna opinion, we need to make some efforts in this some kind of digital divide between our secondary education and higher geographic education. Yes, we use the same, almost same software, but when we try to make it on the bachelor level, we need appropriate support from the special subjects and methodical subjects. On the level of master, we need to extend the skills of the bachelors of our geographic education bachelors. It's teachers with actively involved in educational process. They use the related software and tools in their schools. So the university goal is to extend their abilities and make some bridge between the school and university education. Different software to the single goal, to make our prospective teachers, not only prospective, our forward teachers to the future of geographic education. I would like also introduce the laboratory for geoinformation technologies, which works in the KRYVYI State Pedagogical University. Geoinformatics, also educational geoinformatics, is the main trend of this laboratory in the last 2 decades, in my opinion. Я також додав, Ольга Володимирівна, те, що на нашому факультеті працює відповідна лабораторія геоінформаційних технологій, і, власне, саме забезпечення навчання наших вчителів ми бачимо у синергії того, що їм доступно у наших просунутих ліцеях, зокрема, краще обладнаних, ніж наш університет, і та програмна і методична підтримка, що ми можемо надати, щоб дійсно зробити найкращих випереджальних наших вчителів географії для цифрового суспільства. Дякую.
Thank you.
So, thank you a lot for questions. And we continue our talk about educational technologies, digitalization of educational process. And the next speaker is Irina Zinovieva from Kyiv National Economics University, Institute for Digitalization of Education of the NAES of Ukraine.
The topic is offered for your attention, the use of GIS in renewable energy specialist learning. The global trend of recent decades in the gradual replacement of traditional energy sources with renewable ones for improving the environment, climate change prevention, and others. Aiming technologies that help increase the efficiency of renewable energy resource, RIR, are Geographic Information System GIS. Modern GIS offers a lot of functionality for the entire decision cycle. In particular, for solar generation, GIS can be used for solving difficulties of remote monitoring of sites allocated for solar power plants and assessment of their suitability. Effective management of information on the operation of stations, production and distribution of electricity in real time. Planning and management of energy production resources. With the development of GIS, scientists and energy professionals are finding new and new applications in the field of renewable energy resource. At the same time, it is important to pay attention to the need for high-quality training of highly qualified specialists in the field of RAR in order for GIS to become a truly effective management tool in their professional activities. According to the results of research in the world, in most student training programs in the field of renewable energy resource is insufficient attention paid to the study of GIS, in particular open source software. The educational and professional training program for students measuring in 141 electricity, electrical engineering, and electromechanics is focused on training primarily competitive professionals who have developed professional competition in the field of RR, capable of designing, creating, and operating power plants using renewable energy sources. Currently in Ukraine, such specialists are trained in 18 higher education institutions. You can see in figure. Chernivtsi National University, named after Yuri Fedkovich. Kherson National Technical University. National Technical University of Ukraine, Kyiv Polytechnic Institute, named after Igor Sikorsky. National Aerospace University. Zhukovsky Kharkiv Aviation Institute, Kharkiv National University, named after Beketov, National Technical University Dnipro Polytechnic, National University Odessa Polytechnic, and in Ivano-Frankivsk National Technical University of Oil and Gas. Education takes place according to the educational programs of the first bachelor's, second master's, and third educational scientific levels of higher education. One of the areas of the potential application of knowledge of future specialists in the fields of renewable energy resources is social environmental, which should address issues related to the efficient use of natural resources, environmental protection, the openness of government, land management, and more. Most of them are based on the development, implementation, and use of geographic information system and technologies. The functionality of GIS as follows. First, data entry by importing from existing digital data sets or by digitizing sources. Data conversation, converting data from one format to another. Transforming map projection, changing coordination system, storing, manipulating, and managing data in internal and external databases. Map metric operation, geodetic data processing operation, overlay operation, cartographic algebra operation. Special analysis, a group of functions that provides analysis of the location, relationships, or other special relationships of objects, including analysis of visibility and invisibility zones, approximately the analysis, network analysis, creation and processing of digital terrain models, analysis of object within buffer zones. Spatial modeling, geomodeling operations similar to those used in mathematical cartographic modeling and cartographic research methods, visualization of input, derivative or final data, output of data, graphic, tabular, and textual documentation, including its reproduction, documentation, and generation of reports. Maintenance of decision-making process. According to the authors, the need to study GIS by future specialists in the field of renewable energy resource is justified, at least, but professional conditionality and orientation, social significance, and professional demand, you can see in figure. The purpose of the discipline is to acquaint future engineers with the theoretical, methodological, and technological basis of the creation and operation of geographic information systems, mastering the general principles of work, and gaining practical skills in using GIS to solve applied problems. Such tasks include acquisition by applicants of knowledge and skills necessary to work with modern geographic information system, and formation of skills of future specialists in the practical use of standard geographic information system to solve applied problems, in particular use of mapping skills in design and operation of alternative energy stations, use of instruments of geospatial measurements on the Earth's surface, assessment of the suitability of land allocation for alternative energy station, vectorization and geometrization of areas allocated for renewable energy sources, analysis of climatic condition and their impact on the georesource plantation of the environment, remote monitoring of sites and operation of the alternative energy station, management of information on electricity generation and the distribution on real time, planning and management of energy production resources. The introduction of the discipline GIS for renewable energy resource specialist in the educational process of training specialist is a field of RER pursues 3 groups of goals which are described in table 1. Based on the results of the analysis and the task of developing professional competitions with the discipline GIS for renewable energy resource specialists, the author team was chosen as the leading toolkit of the course CAJA GIS. Rationale. CAJA GIS abbreviation for System for Automatic Geoscientific Analysis, specialized software designed for scientific geospatial analysis and modeling of open source data. Availability of the necessary functionality for training needs. The following types of data are supported: bitmaps, tablets, and databases, ERS data, vector object, and metadata. Legal and free use of software for the needs of the education process, use under the GNU General Public License. Technical and hardware requirements of GIS, complements of the description of technical documentation. Measurement of the area of SAS Starokozache, Ukraine, Odessa region, using Google Earth, and determining the average level of precipitation in Ukraine in the first quarter of this year, December, January, and February. Today, GIS is only gaining momentum in Ukraine, which is facilitated by several factors. Firstly, the reform of most branches of government in order to make their work more transparent and therefore efficient. Secondly, the development of an appropriate legislative framework, as well as the formation of a unified strategy for the development of the digital economy. For Ukraine, the use of GIS for the most part is characterized by the following characteristics: narrow coverage, there is a significant growth potential, tendencies to develop their own software products based on existing GIT. GIS is not universal in nature, but is aimed at solving specific problems. The use for the most part of information and reference and cartographic function, insufficient use of the potential of the analytical capabilities of modern GIS, the feature of the system across platforms, the use of web service and cloud technologies, and integration with geospatial databases. Thank you for your attention. The team of authors who prepared this publication and report is present on the slide.
Dear speakers, thank you for your presentation. Colleagues, do you have any questions?
У мене є запитання до авторів. Скажіть, будь ласка, чому саме ця ГІС пропонується для навчання студентів? Які вона має переваги порівняно з тим же РГІС або іншими ГІС доступними у вільному доступі?
Вітаю. Як мене чути? Бо у мене проблеми зі зв'язком, я не впевнена, чи я тут не лагаю.
We hear you well. We hear you
Oh,
well.
okay, thank you. So, first of all, our thoughts was about the value of this software, because you know our university and the main parts, or maybe higher educational system in Ukraine have some limits in financing. So we have such good, I thought that this is a good practice, such practice to use in our educational course, free software. So when we try to learn the market of software, GIS software, in the world, and maybe those software that used in Ukraine and maybe in Europe, we choose a few free software instruments, but the Saga, for example, have the most development tools for and instrumentary for decide a lot of scientific tasks, and we decided to stop on it for trying first of all, and then when we using it at practice, it improve us that this software is good, and decided the main our перепрошую, очікування,
Our expectations.
Expectation, yes, thank you. Thank you very much.
Дякую.
And by the way, I want to tell you, or maybe admit, that as you can see, and that we have some issues in our research that is not actual in our nowadays, because the war made some changes that affect on our result of our presentation and our research, but the main purpose, or maybe the main idea that we want to give you, and maybe to reclaim that the GIZ is a necessary instrument, or maybe a necessary part of educational program for maybe every higher educational program in Ukraine, because maybe like a variety part, or maybe like a normal, but in general we confirm that the study of GIZ is a rather important task in the higher education system, and into preparing of specialists in reliable energy. Thank you.
Thank you a lot for such a long answer, but we need to continue. And it will be very interesting to learn more about the technology of creating educational content for open digital resources in general technical disciplines. And our next speaker is Natalia Dotsenko from Mykolaiv National Agrarian University.
They represented the technology of creating educational content for open digital resources in general technical disciplines. The main goal of modern education is to introduce new information technologies into the educational process and management of educational institutions to create free access to cultural, educational, and scientific information. Informatization of education contributes to the development of a system of lifelong learning, which provides an individual learning trajectory for each person. Access of higher education applicants to various sources of information develops critical thinking, and independence provides a creative approach to education. Integrating open education content into training in general technical disciplines is an effective way to overcome the higher education challenges posed by the pandemic and war in Ukraine. The assembly of methods of the research process is represented by theoretical methods, categorical and logical analysis in order to develop the technology of creating educational content for open digital resources in general technical disciplines, empirical methods, surveys, questionnaires, self-assessment, testing, observation of the learning process and educational results, statistical methods, quantitative processing of indicators, and verification of the reliability of the obtained empirical results. The result of the experiment involved 227 higher education applicants. There were 115 people in the control group and 112 in the experimental group. They represented the technology of creating educational content for open digital resources in general technical disciplines. This technology consists of the 4 stages: development stage, design stage, posting stage, and final stage. At the development stage, there were developed video content, interactive content, graphic content for lectures, practical tasks, laboratory tasks, and independent work. At the design stage, creation of materials, selection of text and visual material, creation of presentation, video recording. There were used services for creating interactive content, for interactive tasks, interactive posters, worksheets, dictionary cards, videos, and creation of 3D models for practical and laboratory works. Posting stage consists on the posting the video on the YouTube channel, making settings, getting the implementation code, creating interactive content using the selected service, getting link, QR code or implementation code, and creating of laboratory and practical work with the use of 3D models. Creating a relevant task in an open educational resource, lecture, explanation of practical or laboratory task, test, download the implementation code and create a task. And the final stage consists of the execution of tasks by higher education applicants, obtaining points, acquisition of competencies. There are considered some resources for recording video content. For example, Zoom, Fast Tone Capture, and Camtasia Studio. Advantages of Zoom, it is when using this program are the ability to share the screen with the sound. FASTM capture is a functional program for creating screenshots. Camtasia Studio allows to edit a clip after creating it. There is an option to add audio and video tracks to the project, compile and edit them. Interactive technologies for general technical disciplines in the context of creating open educational resources were made by the learning apps, the Edpuzzle, the ThinLink, the interactive worksheet in Google Docs, the Quizlet, and H5P. The Learning Apps Interactive Task Designer is created to support the learning process with the help of interactive modules exercises. Edpuzzle is an online service for creating video clips with the ability to add voice comments and questions from the material. The ThinLink service is a tool for creating interactive infographics or interactive posters, interactive map, diagram table. Furthermore, its capabilities extend to other methods of multimedia didactics. The Quizlet service for creating dictionary cards allows to memorize information that can be presented in the form of training cards. H5P is a handy designer for creating interactive tasks based on templates. It is possible to create videos, assignments, questionnaires, quizzes, and more. Graphic content were made in 3D Max, in AutoCAD and SketchUp. 3D Max, in this program, it's possible to make three-dimensional models. There is a built-in physics and kinematics as systems of particles. It is easy to build an animation and get video. Autodesk is a more specialized environment that is used mainly by engineers, architects, and other design professionals. SketchUp is a very easy-to-use program for simple modeling of buildings and interiors. There are some examples of video educational content for open digital resources in general technical disciplines. For example, a video lecture on the topic axonometry, video instruction to practical work 3D modeling of engineering objects, video lecture the main concepts of mechanic materials and constructions, and video instruction to laboratory work drawing of the details. Also, there are some examples of interactive educational content for open digital resources in general technical disciplines. For example, interactive poster to practical work beam bending, interactive element of engineering and technical project theory of mechanisms and machines, interactive test beam torsion in the context of the disciplines mechanics, materials, and constructions, and interactive poster to practical work kinematic analysis of mechanism. Graphic educational content for open digital resources in general technical disciplines on this slide is presented by instruction for graphic work drawing of the detail, virtual laboratory work drawing structural elements of the equipment, execution of practical work on the topic 3D modeling, and execution of practical work on the subject details of machines on the topics electric motor. In order to statistically verify the quality of use educational content for open digital resources in general technical disciplines, in control and experimental groups, there were formulated hypotheses. The first, there are no significant difference in the level of application of educational content for open and digital resources in general technical disciplines, and according to the second hypothesis, there are significant difference in the level of application of educational content for open digital resources in general technical disciplines in the control and experimental group. So, before the experiment, we can conclude the deviations between distributions are insignificant, and after the experiment, deviations between distributions are significant. The process of informatization of education, which have recently become more widespread, are aimed at the digitalization of educational resources. The proposed technology consists of the following stages: development, design, posting, and final. The development stage outlines the methodical peculiarities of creating video, interactive and graphic content for different forms of classes, lectures, practical and laboratory classes, and independent work. Video content includes video lectures, video instructions for practical and laboratory work, video recording of the speech of higher education applicant. Interactive content consists of the lectures and labs with interactive elements, interactive posters, and tests. Graphic content include creation of lectures with graphical models, 3D models for laboratory works, performance of practical works with the use of modeling and design program, and creation of engineering and technical projects. There are outlined services for achievements of the educational purposes for creating each type of content at the design stage. At the posting stage, the tutor downloads the relevant task in open digital resource, and final stage takes into account the execution of tasks by higher education applicants, obtaining points, acquisition the competencies. The result of using proposed technology is achieving competencies in general technical disciplines in the conditions of open digital resources. It is determined that the technology of using educational content for open digital resources in general technical disciplines is effective. Thank you for your attention.
Thank you for such an interesting presentation. And now we are ready to ask you some questions.
Greeting to all conference participants, for the conference organizers. That's very pleasant to take part into this meeting. So maybe someone have some questions.
У мене є запитання, пані Наталі. Ви говорите про технологію створення навчального цифрового контенту. Скажіть, будь ласка, де він зберігається? Бо я так розумію, що може зберігатися в якомусь загальному місці на кшталт мультимедійної якоїсь бібліотеки, чи він розпорошений по різним місцям, відео це на платформі YouTube, наприклад, а інші речі в іншому місцях. І хто має доступ до нього? Тільки виключно ваші студенти? Чи, наприклад, всі, хто у нас має відношення чи стосунок до загальнотехнічних дисциплін, може користуватися напрацьованим вашим науковим доробком?
Дивіться, це може, if it's, I'll try to answer in English. So there are plenty of options. If there is open доступ to the content, yes, everyone can use it. For example, according to the app learning apps, yes, there are tutors profile, and you can choose which type. So it is possible to all who are registered on this platform to use these interactive tasks, yes, interactive posters, interactive maps, and so if you want, you can close the access. Also, in the conditions of our university, we make courses, yeah, in our digital platform, and to these courses only students of our university have the access, but the elements, a lot of elements are in the open access. Thank you for your question.
Thank you.
Yeah.
What kind of interactive actions does your resource have? In your presentation, I saw only picture and draw What do you mean? You say interactive educational content.
Mhm. I'll try to demonstrate my screen if it will be possible. Yeah, you see my screen, yes?
Yes.
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 For example, this is in the right space of the screen. This is an element of the interactive poster. If you press on these circles, you can see the stages of implementation, the task in the context of the task of theory mechanisms and machines. When you press these circles, yes, there can be some pictures, some explanations in text, some videos, etc. So it is like an interactive poster.
Thank you very much.
Okay, so the next speaker is Tatiana Derkach.
Thank you for your attention.
Okay, thank you too. And the next speaker, the representative of Kyiv National University of Technologies and Design, Tatiana Derkach, will tell us about project-based learning as an approach to enhance ecological component in professional education.
I'm glad to present our team report, Project-Based Learning as an Approach to Enhance Ecological Component in Professional Education. Recycling is a market requirement but is poorly supported by education. The educational standards of Ukraine don't prescribe competencies regarding recycling as an ecological component of education. Our research aims to determine the necessary changes in educational programs to implement approaches that will contribute to forming professional competencies in the future and today contribute to improving the understanding of the environmental component in professional education. In the previous study, the behavior of students regarding upcycling and the influence of various factors on their behavior was studied. These factors are defined following the model of theory of interpersonal behavior and the theory of planned behavior. We obtained two important results. First, students don't understand the benefits of using upcycling at all. The second result is that there are optimists and pessimists about upcycling. You see this picture. On the left are those who use upcycling very rarely, for example, once a year, and on the right, often, for example, was every 1 or 2 months. Now, let's try to understand the nature of the appearance of these optimists and pessimists and the influence of individual factors. One gets the impression that such a distribution has natural causes. Some people are eager and some aren't interested at all. According to the research results, we compared the influence of various factors on forming such conditional groups, optimists and pessimists. You see this, skeptics and optimists. A table with a comparison according to the Mann-Whitney model is presented. In the table, those factors that are influential are circled in red. We can compare the relevant coefficients for each of them. There are 4 factors which have a significant influence on the formation of skeptic and optimist subgroups: attitude and intention and subjective norm and perceived behavior control. At the same time, there is a certain discrepancy between self-reported attitude of students and the actual upcycling behavior. You can see two pictures with attitude on the left and the upcycling behavior of students on the right. In words, most respondents have a highly positive attitude to upcycling. In practice, only about half confirm their words with actions. It's a consequence of two things. They don't understand why it's necessary. The second time, it's affected by the onslaught of fashion. Ecology is fashionable. We used problem-based and project-based learning to form a graduate profile adapted to work in modern garment production and to strengthen the environmental component in engineering education. This slide demonstrates you the total scheme of our experiments. You see the total numbers of students, bachelor's and master students of KRYVYI for different specialties. Among them, 22 students specialized in the design, 36 studied the technology of clothing, industry products, and 35 specialized in vocational education and training. VET. I will use this abbreviation in what follows. You can see the model as a way of 9 factors influencing upcycling behavior compared to the frequency of upcycling practice. And you see the group, experimental group, and a group of students without any training, the special training. Programs of 2 disciplines, you see the names of these disciplines, was used to practice the skills of working on individual elements of PBL and PGBL methods under the guidance of teacher. The second was used for the independent creation of PGBL student project. Environmental projects devoted to the organization of waste management in the textile industry occupied a significant part of the topic. So you see our experimental group and result. We can compare the relative numbers of observation as a function of the scores for the perceived benefits for groups of junior in green and senior in white students of the specialties technology and design without special training, and for groups of students of WET education. You see this specialty. In our conclusion, if you don't conduct experimental training, the indicators of junior and senior years almost don't change. It means that the exciting curriculum doesn't provide an environmental component. For experimental group, the conducted training significantly changes the situation. An advantage of upcycling optimist appeared, which was not present before the study. You see this changing as this curve. Mathematical calculation supports the conclusion about the changes. We see the equation that describes the curves. You see approximation peak for skeptics and for optimists. Please note the highlights in red. More than 0.9 means that the mathematical curve is very well described. See the excellent fitting for these curves before experiment. you can see bimodal curve, and after the experiment, unimodal curve. However, for juniors, the coefficient is very small at 0.5. We can't say for sure, maybe because the groups were small. However, for senior students, you can see this coefficient 0.8. The unimodal character is more obvious. There are two options for training, either the introduction of special disciplines or the introduction of modules into exciting disciplines. Both have the right to life. We checked one and can't say anything about the other yet. It's necessary to use established terms to understand the effectiveness of the study. I mean, learning outcomes and acquire competencies. At the same time, the necessary competencies aren't formulated in the modern approved standards of Ukraine. So, based on the study of European programs, we have determined those competencies and program learning outcomes that are important. You can see this competence definition of these competencies and most common descriptors for learning outcomes. You can find a description. You see only example. There are 7 such an important competencies for sustainable education. You can find a description of other competencies in the full text of our article. Perhaps it will be useful when updating educational programs and provide an opportunity to consider the European experience. Further research aims to formulate competencies and learning outcomes for further changes in educational programs. You can see the total conclusions of our research, and I thank you for your attention.
Thank you for your presentation. You were quite persuasive, but we have some questions for you too.
Можна я задам запитаннячко? Значить, пані Тетяно, от оцей апсайклінг, у вас він звучить як основа для розвитку саме екологічної складової в навчанні. А в мене таке питання, все ж таки, ну, на вашу думку, це більше екологічна якась розвиток екологічних компетенцій чи творчості? Бо там, мені здається, дуже багато творчості потрібно.
Yes, as you can see in European competencies, the main of them is creativity. So, I mean creativity and ecological competency together in between, maybe between creativity and ecological competency or together.
So has anybody else questions? Or that's it? So I think if nobody has any questions, we can finish our conference. So thank you for taking part in our conference today. The last presentation was delivered, and we are looking forward for further cooperation. Stay safe and goodbye.
Thank you very much.
Goodbye.
Thank you very much.
Thank you,
Goodbye.
Oleg. Goodbye.
Many thanks.
Many thanks for your hard work. Thank you.
Дякуємо, до побачення.
Thank you.